Good morning, teachers. Today we're going to be talking about turtle graphics. And turtle graphics are a very big part of teaching programming in a very concrete way, especially the elementary school ages. It has a long history. Really, we started with robots that you could control with what were rather large computers of the day, and basically tell them to roll around the floor. And these robots had a pin attachment where you could put just a regular old marker in there and then put paper under the robot, and it could lower the pin and drag it as it moved, drawing lines. And as we got more advanced displays in our computer systems, we replaced the robot turtle with one that would appear on the screen. We found out pedagogically it was just as effective at making programming concrete through drawing. So it's a really good technique. So at this point, you've already seen this program. You've run it and you've looked through the blocks and tried to understand what this program is doing. I'll go ahead and run it again just so we can see. Yep, it draws a triangle, which is kind of what we expect. The name of this program is actually Draw a Triangle. So this really meshes with what we're expecting. Now, let's go ahead and explore this, and I'll talk you through what each of the blocks do, and you can confirm what you thought or correct if you had a misconception about a particular block. First of all, let's notice that these blocks have kind of a pin icon on them. And if you open up Scratch, it's not there by default. Notice this pin is added at the very bottom. And if you remember when we did the music extension, it added music blocks that had a little icon of music notes. And so you might be thinking, oh, I bet that pin is an extension. And you're absolutely right. If you come down to the added extension, it's this pin extension. And the pin is basically the mechanism that Scratch has used to implement the idea of turtle graphics within Scratch. So the pin blocks actually work with any sprite. It doesn't have to be a turtle. But I went ahead and created this cute little turtle sprite for tradition's sake to introduce this program. Now the other thing I'll point out about this turtle is we've actually scaled it down. If I duck down a little, you can see its size is 20%. So it's actually been scaled down from what it normally would be, so we can really see these lines as it's drawing them. And you can control that by basically just putting in the value here. Or there's this looks menu, and we have a looks block that will actually change the size to a percentage, or set it to a percentage, or we can change it by a percentage. So we can increase or decrease it by using a positive or negative percentage change. So that is something that you can play with down the road if you're interested. The other thing I'll point out is our turtle has an X and a Y position here. The X is where it is on the horizontal axis, and the Y is where it is on the vertical axis. And this is really laid out the same way that we teach in geometry. The origin of our coordinate system is right in the center of the stage, and it increases in an upward direction and decreases in a downward, the Y does. At the very top, that's positive 180. At the very bottom is negative 180. And then the X-axis increases as we go to the right, up to 240 is the edge of the stage, and decreases as we go to the left, with negative 240 being the other side of the stage. So this really aligns well with your math courses if you're teaching geometry, if you're teaching the Cartesian coordinate system. That's actually what Scratch largely is using. We also have this point in a direction. Notice over here we have a direction of 90 degrees. This is a little bit different than the Cartesian coordinate system in that in Scratch, the 0 angle is actually straight up, and then it increases in a clockwise direction, which I know is a shift from those of you that have taught geometry. That's not how we teach geometry. I think they did this to closer align with using clocks to teach angles, which is a common way of doing it in middle school, where the hands, when they're pointing straight up, it means you're at 0 or 12 o'clock. So I think that, and then the rotation is positive around the clock, which is the opposite of our coordinate systems that we're used to from Cartesian coordinates. But I think that's why they made that change. So just be aware that that is a bit of a difference that you'll run into. Also, if you do graphical programming in something other than Scratch, you will probably run into a slightly different coordinate system that we use in computer graphics, where we actually put the origin at the upper left-hand corner, and the y-axis increases in a downward direction. And that's really legacy from when we were using cathode ray television tubes, because they would actually scan across the screen, starting in that left-hand corner, go all the way to the far side, drop down a line, and scan across. So what we consider reading order in America. So If you do some graphics programming in other frameworks, they're going to use a different coordinate system. Scratch really, when they developed it, I think they really paid attention to what's being taught in the elementary schools and tried to adopt as much of that coordinate system as they could. So now that we kind of have an idea of where our turtle is on the stage, let's walk through our program. So the when green flag is clicked, you've seen this block before. It basically is what corresponds to clicking this flag, and when that happens, it starts running the program by invoking the next block or making the next block in the stack do its thing, followed by the next block, followed by the next block. So that's the sequencing we learned when we did Scratch music. This next block, point in direction 90, is what recenters our tortoise, makes it look back in this direction. So it will always go back to facing down the 90-degree axis when we run that block. Then we have the go to X and Y, and we have -50, -50. So that's moving us into our coordinate system to a position that's 50 degrees down from the origin, or 50 units or steps down from the origin and 50 steps backwards from the origin. Then we have this erase all block, which is one of our pin blocks that we added here. And you can kind of think of this Scratch surface, or the stage, as a whiteboard, and the pin as being a whiteboard marker. So the erase all, you might think, is going to erase that whiteboard and bring us back to a pristine state. If we double click on that, it will erase it. Then we have the pin down. Again, this goes back to that turtle robot, where it could raise and lower that pin so it will draw on the paper. The pin down block says go ahead and start drawing. Now it pin's down on the surface, and as we move our robot around, it's going to draw a line. And the corresponding pin up block raises that pin so that as we move around, we don't draw a line. So we just make sure that pin's down before we do our movement to draw our shapes. And then we have repeat, this funny little block. This is what we call a C block because it's shaped like a C, and because we clamp these other blocks inside of it. And you might be thinking, what does this do? Based on the name, repeat, and the fact that there's a 3 here, and we saw it draw a triangle, we might think it does whatever's clamped inside 3 times. That's what you guessed. You're absolutely right. It repeats a command, or whatever blocks are clamped inside that many times, and then when it's done doing that, it will just continue down. Now, our program doesn't have anything snapped underneath it, so at that point, we're done with our program. Now, the blocks that are inside, we have move 100 steps, and you might say, well, that probably makes the turtle take 100 steps forward, and that's absolutely true. So whatever direction it's facing, it's going to move 100 steps that direction. And then we have a turn of 120 degrees. So you're thinking, oh, well, that will make him turn 120 degrees. Then we repeat that, so he moves another 100 steps upwards and to the left a little bit. And then we turn 120 degrees again, and we move down again. And that's where we stop. And if we run that program again, you can see that's exactly what it does. So now you understand what this program does. And we're going to pause, or basically stop here. You're going to move forward in your lesson. The next thing we're going to ask you to do is actually modify this code to do some different kinds of things with it. So go ahead and do that. And after you've done that, we'll come back and I'll have another video where we're going to kind of pick up after those actions and do some more interesting things with Scratch. So I will see you in a little bit.